So I'm going to do one of each example from the review. If we have time, I'll come back and do more, but just so we can see a little bit of everything. So starting with number 1, we're going to find a polynomial function with real coefficients given the zeros. So we know if we have a complex zero, they happen in conjugate pairs, so I would need its conjugate to also be a 0. So if I have -1 plus 3i, that means -1 minus 3i would also be a 0. Same with the square root of 2. If I have positive square root 2, negative square root 2 would also be a 0. So when I write this out in factored form, it's always x minus whatever the 0 is. So x minus -1 minus 3i. Then x minus -1 plus 3i. X minus 4. And x minus negative square root 2, which will turn into plus square root 2. And x minus square root 2. So we have 5 zeros here total. So when we FOIL this out, we're going to end up with x to the 5th power. We always want to FOIL our conjugates together first. So I'm going to start by FOILing out the first 2. So before I even FOIL them, I need to make sure I distribute the negative. So this turns into x plus 1 plus 3i and x plus 1 minus 3i. You can FOIL this out, or you could do your conjugate shortcut. But be careful when you do your conjugate shortcut. The conjugates are separated by a plus and a minus. So when we do our a squared minus b squared, our a would be x plus 1. So we've got x plus 1 squared minus 3i squared. So we have to FOIL x plus 1 squared out. So we got x squared plus 2x plus 1 when we FOIL that. Then minus 3i squared. We distribute the squared to the 3 and the I, so this would be minus 9i squared. And what does I squared change to? -1, so that becomes a plus 9. So this would be x squared plus 2x plus 10. So that's what we get when we multiply our first 2 zeros together. So when you're combining your conjugates, those complex conjugate pairs, it'll get rid of the complex number. So if you have an I, the I ends up going away. You're not going to have an I in your answer for these. Or if you have a square root, the square root's going to end up going away. So you're not going to have a square root in your answer. Next, I want to multiply the other conjugates together. So here we just have x plus square root 2 and x minus square root 2. So when we do our a squared minus b squared, we get x squared minus square root 2 squared. So square root and the squared cancel, so this would just be x squared minus 2. So now I have x squared plus 2x plus 10, x minus 4, and x squared minus 2. The order that we multiply these 3 things in doesn't matter. You can do whatever order you want. If you want to multiply x minus 4 and x squared minus 2 together, you can do that. I'm just going to multiply x squared plus 2x plus 10 to the x minus 4. So I'm going to multiply these together next. And then I'll multiply the x squared minus 2 at the end. So here you just have to make sure everything in the first set gets multiplied to everything in the second. So we have x cubed minus 4x squared plus 2x squared minus 8x plus 10x minus 40. When we combine our like terms, we get x cubed minus 2x squared plus 2x minus 40. And then we still have to multiply this to the third part here. So that x squared minus 2. So we got x to the 5th power minus 2x cubed minus 2x to the 4th power plus 4x squared plus 2x cubed minus 4x minus 40x squared plus 80. So x to the 5th power, I'm just combining it and putting it in standard form. Minus 2x to the 4th power. The 2x cubes cancel. We have a negative 2x cubed and a positive 2x cubed, so those cancel out. 4x squared minus 40x squared would be minus 36x squared minus 4x plus 80. And then the very last step here, we just have to name it as a polynomial, so just make sure you put that f of x in your answer. So that would be our answer. There's a lot of multiplying going on here. Just be organized with your work. Be careful here. And don't forget that complex numbers happen in conjugate pairs, so do not forget the pairs. All right, let's take a look at number 1 in the next part. It says, use the given 0 to find all the zeros of the function. So we're given that 3 plus 2i is a 0. We know that its conjugate pair is also a 0, so that means 3 minus 2i is a 0. So we want to find the factor that 3 plus 2i and 3 minus 2i come from. So I'm going to put these in factored form. I've got x minus 3 minus 2i and x minus 3 plus 2i. We want to FOIL these together so we can find out a factor of our polynomial. So before I multiply them together, I need to distribute the negative. So we have x minus 3 plus 2i and x minus 3 minus 2i. Again, these are conjugates, so we can do our conjugate shortcut, a squared minus b squared. So our a here is x minus 3. So x minus 3 squared minus 2i squared. So we get x squared minus 6x plus 9. This would be minus 4i squared. And what does I squared change to? Negative 1, which makes it a plus 4. So x squared minus 6x plus 13 would be our factor. So if we know that x squared minus 6x plus 13 is a factor of our polynomial here, how do we find the remaining factors? Long division. Awesome. So we have to divide. We've got x squared minus 6x plus 13. We're dividing that into x cubed minus 11x squared plus 43x minus 65. Just like before when we did long division, make sure none of your terms are missing. If they are, you need to make sure you put a 0 in that spot. So x cubed divided by x squared would be x. We're going to multiply that times everything outside, so we get x cubed minus 6x squared plus 13x. Change the signs and combine. So x cubes cancel. This would be negative 5x squared plus 30x. Negative 5x squared divided by x squared would be negative 5, so minus 5. Multiply that times everything out front. We get negative 5x squared minus plus 30x minus 65. Change the signs and combine. Everything cancels. Is that a good thing or a bad thing? Good thing. Everything in this step is supposed to cancel out because what we divided into it was a factor, so it's going to divide in evenly. Your remainder is going to be 0. That was your goal, is to get the remainder to be 0. Now, the question asks us to find all the zeros. With what I have so far, how can I find my remaining 0? What would I need to do? If x minus 5 is a factor, how do I find the 0? Set it equal to 0. So x equals 5. So x equals 5, x equals 3 minus 2i, and 3 plus 2i. These are 3 zeros here. And since it was x to the 3rd power, we knew we were going to have 3 zeros. So let's take a look at number 2. So it gives us the zeros. We have to come up with the polynomial now. So we know that if we have a complex 0, we need its conjugate pair to also be a 0. So what are we missing here? So positive square root 8 and 4 plus 5i. Awesome. How many zeros do we have total? 5. So when we multiply this all out, we're going to end up with x to the 5th power. So let's put it in factored form. It's always x minus whatever your 0 is. So x minus 0 would just be x. And then we have x minus square root 8. X minus negative square root 8 would be x plus square root 8. X minus 4 plus 5i. And x minus 4 minus 5i. So we always want to multiply our conjugate pairs together first. So we can multiply these two out together first. You can do your conjugate shortcut, so a squared minus b squared. So we get x squared minus square root 8 squared. So square root and the squared would cancel. So this factors or foils into x squared minus 8. Now for the next pair, we want to simplify before we multiply it out. So we got x minus 4 minus 5i, x minus 4 plus 5i. So these are conjugates. They're separated by a minus and a plus. But we just have to be careful when we do our shortcut. If we do a squared minus b squared, our a is x minus 4. So we've got x minus 4 squared minus 5i squared. So x minus 4 squared would be x squared minus 8x plus 16 minus 25i squared. We have to square the 5 and square the I. And what does I squared change to? -1, so that would make it a positive 25. So this would be x squared minus 8x plus 41. So now I can multiply these two together. I'm going to write them next to each other just so we can see it a little bit better. Just make sure everything in your first set gets multiplied to everything in the second. So x squared times x squared would be x to the 4th power minus 8x cubed plus 41x squared. And then negative 8 times x squared would be minus 8x squared plus 64x minus 41 times 8, which would be 328, so minus 328. I'm going to combine my like terms. So we have x to the 4th power minus 8x cubed. 41 minus 8 would be 33. So plus 33x squared plus 64x minus 328. Last step is we still have that x to multiply. So that x that we had out front, we have to distribute that to everything. So we'll end up with x to the 5th power minus 8x to the 4th power plus 33x cubed plus 64x squared minus 328x. Very last step is you have to make sure you name it as a function. So you can put f of x, g of x, whatever you want. Just make sure you put what it's equal to. So looking at the second one. So it gives us -2 minus 5i. We know that its pair is also a 0, so what would the conjugate pair of this be? -2 plus 5i. Perfect. So we've got 2 zeros. How many total are we going to have here? We're going to have 3 total. So we need one more. So we want to put the 2 that we have in factored form, multiply them together to see what a factor of our polynomial would be. So then we can find the remaining factors. So let's multiply these out into factored form. So we have x minus -2 plus 5i. and x minus negative 2 minus 5i. So this turns into x plus 2 minus 5i and x plus 2 plus 5i. So these are conjugates. We can do our shortcut. Conjugates are separated by the minus and the plus. So we have a squared minus b squared. Our a would be x plus 2 squared minus our b is 5i squared. So when we FOIL out x plus 2 squared, we get x squared plus 4x plus 4 minus 25i squared. And what does I squared change to? Negative 1, so that makes it a plus 25. So we have x squared plus 4x plus 29. So this is a factor of my polynomial. How do I find the remaining factor? Long division. Awesome. So we're going to divide it by x squared plus 4x plus 29. Just like when we were doing long division before, if you're missing a term, make sure you put 0 in that spot as a placeholder. But here we're not missing anything, so we're good to go. So we divide x cubed by x squared would be x. Multiply by everything out front, so we get x cubed plus 4x squared plus 29x. Change the signs and combine. X cubes cancel. This would be 7x squared. 57x minus 29x would be what? 28x. Then 7x squared divided by x squared would be 7. We multiply that times everything out front, so we get 7x squared plus 28x. 7 times 29 is 203. Change the signs and combine. Everything cancels. Is that a good thing or a bad thing? Good thing. You need everything to cancel in this step. What you're dividing into it is a factor, so it's going to divide unevenly. Your remainder is going to be 0. If you end up with a remainder here, you did something wrong. Either you FOILed it together wrong in the beginning, or you divided wrong. You did something wrong. So you'll end up with 0 here because you know that what you're dividing into it is a factor. How do I find my remaining 0? What would I do? Set it equal to 0. I set what I just found as my answer, that x plus 7 equal to 0. So what would x equal? Negative 7. I said that I had 3 zeros here. What are my other zeros? Negative 2 minus 5i and negative 2 plus 5i. Awesome. The one that was given and the one that was implied and the one that we found. Next page, we have our rational functions. So let's do a couple from the first part. It says find the domain, vertical and horizontal asymptotes, and the x-intercepts of the following. So let's look at 5. How do we find the domain? What would we do? Set the denominator not equal to 0. Perfect. So here, how would we solve? What would we do? We can divide everything by 3. Let's take out our GCF. So we get x squared plus x minus 6 does not equal 0. Then we can just factor. What are 2 factors of negative 6 that add to 1? Negative 2 and 3, perfect. So I've got x plus 3 and x minus 2 does not equal 0. So x does not equal negative 3 and positive 2. How would I write that for my domain in interval notation? Negative infinity to negative 3. Negative 3 to 2 and 2 to infinity. Awesome. Next, what do we do to find our vertical asymptote? vertical asymptote is the same thing as your domain. You set it just equal to 0. So we already solved when x is not equal to 0. It's going to be the same thing as if it's equal to 0. We just changed the not equal to equal to. So x equals -3 and x equals 2. So your domain and your vertical asymptotes are going to go hand in hand. They're going to be the same values for the most part. Unless you have a hole, then it would affect it. Next, what do we look for our horizontal asymptote? We look at the degree of our numerator and our denominator. So if the degree of the numerator would be 0 and the degree of the denominator would be 2, when your degree of the numerator is less than the degree of the denominator, what does that mean? Our horizontal asymptote would be y equals 0. Don't forget the y equals and the x equals for your vertical and horizontal asymptotes. They're lines, so you need that x equals, or you need the y equals. So y equals 0. And then last it says, find the x-intercepts. What do we do to find the x-intercepts? We'd plug in 0 for y, or just set the numerator equal to 0. So can we have 0 equals 1? No. So here we have no x-intercepts. All right, let's look at 8. So we always want to factor our numerator and denominator just to see if we have any common factors. We want to check for holes first because that'll throw off our vertical asymptotes or our domain. So anything that can be factored, make sure you factor it first. We can factor number 8 here. The numerator factors into x plus 2, x minus 2. And our denominator would be x plus 3, x minus 3. Do we have any common factors? Nope. So no holes. So let's find our domain, our vertical asymptote, horizontal asymptote, and the x-intercepts. How do we find the domain? Set the denominator not equal to 0. So we already did the first step. We can just set the factored form not equal to 0. So x does not equal -3 and +3. How would we write that in interval notation? -∞, -3, -3 to 3, and 3 to infinity. Awesome. What would our vertical asymptote be? X equals -3 and x equals 3. How do we find our horizontal asymptote? We look at the degrees. So when our degrees in the numerator and the denominator are the same, then what do we look at? The leading coefficient. What would our leading coefficient be here? 1. It'd be 1 over 1, which is just 1. So y equals 1. And then how do we find our x-intercept? Set the numerator equal to 0. So our x-intercept, I'm going to write as a coordinate point. We would get x equals -2 and +2. So -2 comma 0, bless you, and 2 comma 0. Just for practice here, how would we find our y-intercept? Plug in 0 into the x's. Awesome. So we got 0 squared minus 4 over 0 squared minus 9. So this would give us -4 over -9, which would just be 4 over 9. So our y-intercept would be 0 comma 4 over 9. Yes. Yeah, I'm going to do one on the next page in the graphing because there's one there that has a hole for sure. I'm not sure if any of these have a hole, but I know that one on the next page does. So I'll do it on the next one. Let's look at 13. So 13, we want to find the slant asymptote and vertical asymptotes. How do we find the slant asymptote? What do? Divide. We use long division. You will only have a slant asymptote if your numerator is 1 degree higher than your denominator. So here we've got x to the 3rd power on the top, x squared on the bottom, so we have a slant asymptote. What would our horizontal asymptote be here? None. If we have a slant asymptote, if the numerator degree is higher than the denominator, there is no horizontal asymptote. So we're going to use long division to find our slant asymptote. Outside, I've got x squared plus 3x minus 1. Inside, 5x cubed. I need to put zeros as my placeholder for the other terms, so 0x squared plus 0x minus 8. So let's divide. What's 5x cubed divided by x squared? 5x. Then we multiply, so we get 5x cubed plus 15x squared minus 5x. Change the signs and combine. So 5x cubes cancel, we get negative 15x squared plus 5x. Divide again, negative 15x squared divided by x squared would be negative 15. Do I need to keep going? No, once you have your x term and your constant, you can stop. Everything else would be our remainder, and you just get rid of the remainder for your slant asymptote. How would I write my slant asymptote? Awesome. Y equals 5x minus 15. It's got to be in the form of y equals mx plus b. So whatever your remainder is, you drop it. So once you get your x term and your constant, you can just stop. No need to find the remainder because you don't do anything with it. The other part of this question says to find the vertical asymptotes. What do we do to find the vertical asymptote? Set the denominator equal to 0. Do we have two factors of -1 that add to 3? No. So what would we do? Quadratic formula. If it doesn't factor, got to do the quadratic formula. Because we may have real zeros here. It just may not factor. But it might end up being an imaginary 0. So if it's an imaginary, then we would have no vertical asymptotes. So let's find out. So our quadratic formula, I'll do it over here, would be negative b plus or minus the square root of b squared minus 4ac over 2a. So we have negative 3 plus or minus the square root of 9 minus 4 times 1 times -1 over 2 times 1. So negative 3 plus or minus the square root of 13 over 2. Is this a real number? Yeah, there's no imaginaries. So it's just not a pretty number. But our vertical asymptote, is it x equals or y equals? X equals. So x equals negative 3 plus or minus square root 13 over 2. Next, we want to find the domain, vertical and horizontal asymptotes, and x-intercepts of the following. So let's do number 9. So first thing I want to do is see if I have any common factors on the top and on the bottom. If I have a common factor, that's going to mean that I have a hole, so it'll throw off my vertical asymptote. So let's see if we have a common factor. I'm looking for my domain, my range, domain, vertical asymptote, horizontal asymptote, and zeros, or x-intercepts. How would I factor out the numerator? How would I factor it? You could do first times last, but looking at it, what else could we do? Take out the GCF. So we're going to take out a 2. When we divide out the 2, we're left with x squared minus 6x plus 8. What are two factors of 8 that add to negative 6? Negative 4, negative 2. So x minus 4 and x minus 2. On the bottom, what are two factors of 12 that add to negative 1? Negative 4 and 3. So we have x minus 4 and x plus 3. Is there a hole? There's a hole. Where's the hole? X minus 4 is the same on the top and the bottom. So we have a hole out. We'd set this equal to 0. So x equals 4. How would I find what the y is in my hole? Plug it in. So I'm going to plug it into the simplified version. So on top, I have 2 times 4 minus 2 over 4 plus 3. So we get 4 over 7. So the y in our hole would be 4 over 7. So you plug it into the simplified version. I'll rewrite the simplified version down here. We got 2 times x minus 2 over x plus 3. Now let's find our domain. What would we do to find the domain? Set the denominator not equal to 0. Do we set the original denominator or the new denominator? The original denominator. So we set the original denominator not equal to 0. We already factored it. It factors into x minus 4 and x plus 3. So x cannot equal 4 or negative 3. So how would I write that in interval notation? Awesome. Negative infinity to negative 3, negative 3 to 4, and 4 to infinity. Perfect. How do I find the vertical asymptote? What would we do? Set the denominator equal to 0. Of the original or of the new one? Of the new one. You can do it of the original. You'll get the same thing, but we had a hole at 4. You can't have a vertical asymptote through your hole, so that would just not be a vertical asymptote. So if you had a hole at that spot, it's not going to count as a vertical asymptote. So now our only vertical asymptote would be x equals negative 3. What do we look for in our horizontal asymptote? We're looking at the degrees. When the degrees are the same, then what are we looking at? The coefficients. So it'd be 2 over 1, which would be 2. Just 2? Y equals 2. What do we do to find the x-intercept? Set the numerator equal to 0. Of the original or of the new one? Doesn't matter. Does it? What do you think? Can I have an x-intercept at 4 if I set the numerator equal to 0? No, because we had a hole there. So that doesn't count, I guess, as 1. So of the new one, you'd want to set the numerator equal to 0. So we get x equals 2. As an x-intercept, we would say 2, 0. And let's, just for fun, let's find our y-intercept. What would we do to find the y-intercept? We plug in 0 into the x's. You'll get the same answer whether you plug it into the original or the new one. It doesn't matter. I would just recommend the new one because the math is going to be easier. But when you're plugging in 0 into the x's, the x's just go away, so you're just left with the constants. So the original wouldn't be too hard either. So we have 2 times 0 minus 2 over 0 plus 3. So this would be negative 4 over 3. How would we write the y-intercept? 0, negative 4 over 3. Awesome. Sure, let's do 12. 14 is probably harder. Let's do 14. All right, so 3x. How do I find the slant asymptote? No. Long division. If your numerator is 1 degree higher than the denominator, that means you have a slant asymptote. So we're going to do long division. So outside the box, we've got 3x minus 2. Inside, negative 3x squared plus 7x minus 4. Oh, yeah. Negative 3x squared divided by 3x would be what? Negative x. Then we're going to multiply that times everything out front. So we get negative 3x squared minus plus 2x. Change the signs and combine. 3x squareds cancel. 5x. 5x divided by 3x would be 5/3. Do I even need to keep going? Why not? What do we do with the remainder? Just throw it out. So it doesn't even matter. So you can multiply 5/3 times everything out front and keep going and find your remainder, but the remainder does not matter. You drop the remainder. How would I write my slant asymptote? Y equals negative x plus 5/3. You only care about the x part and the constant. Once you get your x and your constant, you're done. So you could keep going if you want, but it's just a waste of time. Just divide until you get your x and your constant. Your slant asymptote is going to be in the form of y equals mx plus b. Now this question also asks for the vertical asymptotes. How do we find the vertical asymptotes? Set the denominator equal to 0. So x equals 2/3. Any questions here? So let's look at 16 here. We want to find the zeros. So we'll find our domain, vertical asymptote, horizontal asymptote, slant asymptote, zeros, y-intercept, and holes. So first thing we want to do is factor our numerator and denominator, see if we have any common factors. So factoring our numerator, what are 2 factors of 6 that add to 5? 3 and 2. So we've got x plus 3 and x plus 2 on top. What does the bottom factor into? X plus 3, x minus 3. So do we have any common factors? Yeah. X plus 3 would be a common factor. So we're going to cancel that out. So here we're left with x plus 2 over x minus 3. So we've got a hole at x plus 3. But what would x equal here? Negative 3. How do I find the y in my hole? We're going to plug it into the x's, so we're going to plug negative 3 into the x's, but of my simplified version. So when I plug it in here, I have negative 3 plus 2 over negative 3 minus 3. If you plug it into the not simplified version, you're going to end up with 0 in your denominator, so it'll end up being undefined. So you have to plug it into your simplified version. So we got negative 1 over negative 6, so 1/6. So our hole would be at the point negative 3, 1/6. Now we can put that on our graph because that's technically a point on our graph. It's just going to be a hole. So it'll be an open circle there. So I'm going to go to the left, negative 3, and up 1/6. Put a hole, an open circle there. So now let's find our domain. What would we do for the domain? Set the denominator not equal to 0. Do you think we have to do the original or the simplified version? Has to be the original. Because here we've got 2 values where our denominator can't be 0. That would be negative 3 and positive 3. I'll take it. Thank you. So x can't be negative 3 or positive 3. We got to account for that hole in our domain because we've got a hole in the graph. So we got to show that gap in the graph in our domain. So we have to set the original not equal to 0. So x does not equal -3 or +3. How would I write that in interval notation? -∞, -3, -3 to 3, and 3 to infinity. Now for our vertical asymptotes, what would we do? Vertical. We make the denominator equal to 0. But here we'd want to do the simplified version equal 0, because we're not going to have a vertical asymptote through the whole. So that x equals -3 ended up being our whole. It's not also going to be our vertical asymptote. You cannot have a vertical asymptote through the whole. So we would just want to set the simplified version equal to 0. So x equals 3 would be our vertical asymptote. I'm going to put that on the graph too. So we're going to put our vertical asymptote through 3. Next, let's find our horizontal asymptote. What do we look for our horizontal asymptote? The degrees. So if our degree in our numerator is the same as the denominator, then what are we looking at? The leading coefficient. It doesn't matter here for the horizontal asymptote. If you look at the original or the new one, it'll end up being the same. So it'll be the same value regardless. If you look at your leading coefficients in the original or the simplified version, it ends up being the same. Because here, what would our horizontal asymptote be? Y equals 1. So we looked at our leading coefficients, which would be 1 over 1, so y equals 1. So I'm going to put my horizontal asymptote through 1. Do we have a slant asymptote? No. You only have a slant asymptote when your degree of the numerator is 1 degree higher than the denominator. So no slant asymptote here. You will not have a horizontal asymptote and a slant asymptote. You can't have both. What would we do to find the zeros? Set the numerator equal to 0. Perfect. So here we just set the simplified version equal to 0, because we're also not going to have a 0 through our whole, because our graph is undefined at that value. So we just set the simplified one equal to 0. So x equals -2. So our 0, which is the same thing as the x-intercept. It could ask for either one. X-intercept and zeros are the same thing. So that would be -2. As a point, we'd say -2, 0. So if I put that on my graph, I'm going to go to the left to -2 and stay at 0. Next, let's find our y-intercept. What do we do to find the y-intercept? Plug in 0 for x. So either one, you can plug it into the original or the simplified version. You'll end up with the same answer. So I'm going to plug it into the simplified one. We have 0 plus 2 over 0 minus 3. So 2 over -3. So our y-intercept would be 0, -2/3. So we're going to stay at 0 and go down 2/3, -2/3. So we'd be about there. So I've got a few points on my graph already. I've got 3 there, so 2 points in a hole. Let's plug in a couple more numbers to see how exactly our graph looks. The test is going to say to plug in at least 3 numbers on your graph. So I would say let's plug in something in between 0 and our vertical asymptote, which is at 3. So you could plug in maybe like 1 or 2. It doesn't matter. Pick 3 points to plug in so you can get an idea of how your graph looks. So I'm going to say let's plug in 1. You can plug it into the original or the simplified version. It doesn't matter. It's going to be easier to plug it into the simplified version, so that's what I would recommend. We're going to plug it into x plus 2 over x minus 3. So this is what we're plugging it into. So actually, just to spread it out a little bit more, I'm going to plug in 2. So we've got 2 plus 2 over 2 minus 3. So 4 over -1 would be -4. So I plugged in 2 and got -4. So that's going to be a point on my graph. I'm going to go to the right 2 and down 4. So this gives me a good idea of how the left side of my vertical asymptote looks. I'm going to connect my points here. Remember, as we go out to infinity, our graph is going to get closer and closer to the asymptotes. And then just don't fill in your hole. You have to make sure you keep it as a hole. So our graph will look like this. So this is the left side of our vertical asymptote. We need to figure out what the right side looks like. So we can plug in 4. So 4 plus 2 over 4 minus 3 be 6 over 1. So we plugged in 4 and got 6. So we're going to our graph, go to the right 4 and up 6. So that helps us. Now we know we're above our horizontal asymptote. So our little boomerang shaped graph is going to be above the horizontal asymptote. But just to make it a little bit more accurate, let's plug in another point too. So I plugged in 4. I'm going to plug in 6 just to kind of spread it out a little bit so our points aren't just right on top of each other. So let's plug in 6. We have 6 plus 2 over 6 minus 3. So this would be 8 over 3. So I plugged in 6 and got 8 over 3. 8 over 3 is going to be close to 3. 3 goes into 8 2 times with 2 left over, so it would be 2.6-ish. When you plug in values, you're going to, most of the time, you'll end up with fractions because you're plugging it into a fraction here. Just estimate where your fraction would be. Figure out in between what 2 whole numbers your point falls. So I'm going to go to the right 6 and up 2.6-ish. It's about there. So this gives me a better idea of how my graph looks. As we go out to infinity, we're going to get closer and closer to our asymptotes. We're going to hug the corner here, get closer and closer to our asymptote. So this would be our graph. So let's look at 15. We want to find the domain, vertical asymptote, horizontal asymptote. If there's a slant asymptote, the zeros, the y-intercept, and holes. Yes, 0 and x-intercepts mean the same thing. So let's factor it first, see if we have any holes. Simplify it a little bit. What are 2 factors of -5 that add to 4? 5 and -1, so this would be x plus 5 and x minus 1. Do we have any holes? No. All right, let's find our domain. What would we do to find the domain? Set the bottom not equal to 0, so x does not equal -1. How would I write that in interval notation? -∞ to -1 and -1 to infinity. Awesome. How would we find the vertical asymptote? Set the denominator equal to 0, so it would be x equals -1. What about our horizontal asymptote? None. When the degree in your numerator is higher than the denominator, there is none. What about slant asymptote? We have to do long division. So when your degree is 1 degree higher in the numerator than it is in the denominator, we'll have a slant asymptote. So you'll never have a horizontal asymptote and a slant asymptote at the same time. So let's do long division. X plus 1, no, a yes. You can. This one you can do synthetic division. Just make sure you're plugging in negative or putting -1 on the outside because you have to flip the sign. So we have x, we get x squared plus x, change the signs and combine. X squareds cancel, this would be 3x. 3x divided by x would be 3. Do we need to keep going? No. Once you have your x and your constant, that's your slant asymptote. So our slant asymptote would be y equals x plus 3. Let's go ahead and graph what we have so far. Our vertical asymptote is going to be a vertical line through -1. And our slant asymptote is a line x plus 3. So what's our slope here? 1. And what's our y-intercept? 3. So I'm going to start by graphing my y-intercept. I'm going to put a point at 3. And we're going to go up 1 to the right 1, up 1 to the right 1. I'm going to put a few points just so I can draw my line. So that would be my slant asymptote. Yes?
When graphing the asymptote to slant, you have to make it dotted?
Yeah, for your asymptotes, they should be dotted. All right, let's find our zeros. What would we do to find the zeros? Set the numerator equal to 0. So zeros are the same thing as our x-intercepts. We're just going to set the numerator equal to 0. I already factored it, so I did the first step for us. So we have x equals -5 and x equals 1. So this would be -5, 0 and 1, 0. So we have 2 zeros here. 2 vertical x-intercepts. So I'm going to put a point at -5, 0 and 1, 0. Now let's find our y-intercept. What do we do to find the y-intercept? Plug in 0 for x. So we have 0 squared plus 4 times 0 minus 5 over 0 plus 1. So -5 over 1. How would I write my y-intercept? 0, -5. Awesome. So I'm going to stay at 0 and go down -5. I did. Yeah, I'll fix that. So this, we go down 5. This one should be +1. Left side of your vertical asymptote and plug in a couple numbers on the right side. So we could plug in something like -2. So I have -2 squared plus 4 times -2 minus 5 over -2 plus 1. So this would be 4 minus 8 would be -4, minus 5 would be -9 over -1, so we get 9. So I plugged in -2 and got 9. So I'm going to go to the left to -2 and up 9. So this gives us a little bit better of an idea of how our graph's going to look. Remember, as we go out to infinity, our graph's going to get closer and closer to our asymptotes. So you can plug in points just for the sake of time. I'm just going to draw my graph. But I would maybe plug in another point further to the left of the x-intercept that we have. So you could plug in something like -7. And then you could plug in something like 3, maybe, to give us an idea of how the right side's going to look, but it'll look like this. So as we go out to infinity, we're going to get closer and closer to our asymptotes. Remember, your graphs are going to be functions, so you're not going to have part of your graph on top of another part. All right, on the next page, or I think I skipped the next page because the next one's graphing, but on the next one after that, let's look at 3. We want to use the rational root theorem to find all the zeros. How many zeros are we going to have for number 3? 3 zeros. So we're looking for 3 answers. Our rational root theorem is the last over first, or P over Q. So you want to use the rational root theorem if something doesn't factor. So here, our factors of the last would be 1 and 20, 2 and 10, 4 and 5. And it's the positive and negative of all of these numbers. Our factors of the first would be positive and negative 1 and 3. So we have to try 1 over 1, which would be 1, but also 1 over 3. 20 over 1, which is 20, and 20 over 3. I would always recommend trying the whole numbers first, because once you get down to an x squared, you can just factor it from there. So always try your whole numbers first. See if you can break it down and then just factor it. That way you're not doing synthetic division with a fraction. Even though you definitely can, you just end up multiplying and adding with fractions the whole time. So inside the box I have 3, 2, negative 61, and 20. What do you want to try first? We can try 1. So drop down the 3, multiply, we get 5, add, this would be, multiply would be 5, add, we get too many. It's not going to work. Let's try negative 2. So negative 6, negative 4, this would be 8. Not going to work. Let's try negative 3. Nope, negative 3 is not even a possibility. Let's try negative 4. So then negative 12, negative 10. This would be 40. When we add, we get negative 21. Doesn't work. Let's try negative 5. Negative 15. Add, we get negative 13. Multiply, this would be 65. 65 minus 61 would be 4. 4 times 5 is negative 20. We get 0. So negative 5 works. So one of our answers, x equals negative 5. From here, since we started with x to the 3rd power, our answer is going to start here with x squared minus 13x plus 4. We can just factor this. Once you get down to x squared, you can factor. So if we had, let's say, x to the 4th power that we started with and we were looking for 4 zeros, you may have to do last over first twice, and then you can factor. So you have to break it down until you get to x squared, then you can just factor it. So here I'm going to factor the first time, multiply the first times last to factor. We get 12. 2 factors of 12 that add to 13, negative 13. Would be negative 12 and negative 1. So x minus 12 and x minus 1. Don't forget, if you start by multiplying the first times last, you have to remember to divide. So we get x minus 4 and 3x minus 1. We're looking for our 0, so we just set it equal to 0. We get x equals 4 and x equals 1/3. So I'm going to add those to my list, 4 and 1/3. So those are 3 zeros. If it says find the zeros and you can't factor, you'll have to use your rational root theorem, which is just the last over first, and do synthetic division until you get 0 as the remainder. Any questions here? All right, let's do 5. So we're going to perform the following. Write your answer in standard form. So standard form is a plus bi. The real part comes first. The imaginary part comes second. So just make sure you leave your answer in standard form. Real part comes first. Imaginary comes second. And with these questions, anytime you have I squared, you want to change it to be -1. So those are kind of like, I guess, the two things that you have to keep in mind for these types of questions. And just make sure you follow your order of operations. For number 5, I'm going to FOIL these two terms together first and then distribute the negative at the end. So just be careful when you're doing the math. If I distributed that negative first, make sure it only gets distributed to one set of parentheses. It would be like if I had negative times 4 times 6. You can't distribute the negative to both of them. It's just one negative sign. So it'd be like -4 times 6. So you could distribute it to one set of parentheses first. I'm just going to FOIL it out and distribute it at the end. -7i times 6 would be what? -42i. -7i times 10i would be -70i squared. Plus 66 plus 110i. So let's combine our like terms and simplify. What does I squared change to? -1, which makes -70 what? +70. So 70 plus 66 would be 136. And then when I combine my imaginary numbers together, 110i minus 42i would be what? 68i. 68i. Perfect. And then I still have that negative on the outside and the -8. So I have to distribute that negative. So it becomes -136 minus 68i. And that -8. So again, we're going to combine our like terms, combine the real parts together. So -144 minus 68i. All right, and then down below for number 7, we don't want imaginary and I in our denominator. So we want to multiply the numerator and the denominator by the conjugate. So you can either put the denominator in standard form if you want, or you could just leave it and multiply it by the conjugate of this. It'll end up canceling the I either way. So I'm going to leave it and just multiply by the conjugate. So 10i minus 2 would be 10i plus 2. So just the sign in the middle is going to change. Whatever we multiply to the bottom, we also have to multiply to the top. So 10i plus 2. I'm going to FOIL at the top. So we get -80i minus 16 plus 10i squared plus I plus 2i. I squared changes to -1, so that makes it a -10. So -16 minus 10 would be -26. And then -80i plus 2i would be -78i. Now on the bottom, we can do our conjugate shortcut. So a squared minus b squared. So this would be 10i squared minus 2 squared. So we get 100i squared minus 4. I squared changes to be -1, so -100 minus 4 would be -104. Simplify if you can. How can we simplify here? We could divide everything by 2. Anything bigger that goes into all of them? I can divide everything by -26. If you don't see that right off the bat, start by dividing everything by 2 and then see if you have another common factor. So we're going to divide everything by -26. We get 1 plus 3i over 4. So that would be our answer. Let's look at number 6. So here, Keep in mind when you're dealing with your imaginaries, you want it to be in standard form. So the real part has to come first. The imaginary part comes second. And then anytime you have an I squared, make sure you change it to be -1. So you always want to simplify. So for number 6, we have 9 minus 4i squared. That's like saying 9 minus 4i times 9 minus 4i. So we get 81 minus 36i minus 36i plus 16i squared. I'm going to finish simplifying this before I combine it with the rest. So we can combine our like terms, and we have to change the I squared. What does I squared change to? -1. So -16 times -1, or sorry, 16 times -1 would be -16. So 81 minus 16 would be what? 65? Minus 72i. And then we still have plus 17i. I'm going to distribute the negative now too. So minus 19 plus 5. You could combine inside the parentheses because these are like terms, but it doesn't matter. Either way. Then we want to continue to combine our like terms. I'm going to add the real parts together first. So 65 plus 5 would be 70. Minus 19 would be what? 51. And then negative 72i plus 17i, negative 55i. So that would be our answer. In number 7, I did it with the other class, so it's already in the video. Just remember, you cannot leave an I in your denominator. So if I had something like 1 over I as my answer, how would I get rid of the I in my denominator? Kind of like rationalizing, but what would we multiply by? Well, you can just multiply by I, right? So this would be I over I squared. And what does I squared change to? -1. So this would be negative I. If we had something, so the example that we did, we had like 1 over 2i over 4 plus 6i. If you had multiple terms on the bottom, you'd have to multiply by the conjugate. So here, what would we have to multiply the top and the bottom by? 4 minus 6i. Awesome. So whatever you multiply to the bottom, you have to multiply to the top. What if I had something like I to the power of 501? How would I simplify? Awesome. Divide by 4, and let's see what our remainder is. So I'm going to divide 501 by 4. So 4 goes into 5 once. With 1 left over, 4 goes into 10 2 times. With 2 left over, and 4 goes into 21 5 times with 1 left over. So if our remainder is 1, what would this simplify to? Awesome, I. Just as a reminder, if I had I to the power of 0, so if our remainder was 0, if it divides in evenly, this would simplify to 1. If I had I to the first power, if our remainder is 1, this would be I. If I had I to the second power, this is -1, and I to the third power would be negative I. So if your remainder is 0, your answer is 1. If your remainder is 1, your answer is I. If your remainder is 2, your answer is -1. If your remainder is 3, your answer is negative I. So it says use the rational root theorem to find the zeros. How many zeros are we going to have here? We'll have 5. The rational root theorem is last over first, or P over Q. So we're looking for 5 answers here. Before we even do last over first, looking at all of our terms, what could we do first? Take out the GCF. So our GCF would be x. So we're left with x to the 4th power plus 6x to the 3rd power minus 9x squared minus 44x minus 30. So if I take out an x, do I already have what one of my zeros are? 0. So now I only need 4 more. So if it doesn't factor, you have to use your last over first. So what are factors of our last? So 1 and 30. What else? 5 and 6. 2 and 15. 3 and 10. I think that's all of them. We'll definitely start there for now. Over factors of our first, what's our leading coefficient? 1. So plus or minus 1. So inside the box, we've got 1, 6, -9, -44, -30. What do you want to try first? We can try -1. So drop down the 1, multiply, add, we get 5, multiply -5, add, this would be 14, -14, +14, -30, +30. Does it work? Yes. So we can add that to our list. -1 is also a solution.
You do the factors of the last one over the first one.
Mm-hmm.
And then you have to find 5 zeros from it.
We have to find, well, we had 4 left to find. Because the first one, this gave us 0 as one of them. Noah.
Doesn't that mean you can factor your answer?
If you get x, like if you're left with x squared, if it's a quadratic, or even if it's x cubed and you could factor by grouping, then you could factor. But here, we started with x to the 4th power. This would be x to the 3rd power. You can try grouping. Grouping's not going to work. And it's not x squared, so we can't just factor it. So we have to do last over first again. Our last term is the same, so we're picking from the same options we have here. What would you want to try first?
1.
Sure, let's try 1. So we're going to drop down the 1, multiply, we get 6, add, or multiply, we get 6, add, this would be -8. -8, does it work? No. So as soon as you realize that it's not going to work, try something else. We can try 2. So multiply, we get 2, 7, 14, 0, doesn't work. We can try -1 again. Your zeros can repeat, so keep that in mind. Drop down the 1, multiply, -1, 4. This would be -4. -18 doesn't work. Let's try 3. 3, 8. 8 times 3 would be 24. This would be 10, 30. Awesome. 3 works. So I'll add that to my list. Now that we divided, we took away one more x. This would be x squared plus 8x plus 10. Now you can just factor it. Do we have 2 factors of 10 that add to 8? No. So what do we do if it doesn't factor? Quadratic formula. So to find our remaining 2 zeros, we have to use the quadratic formula. So -8 plus or minus the square root of b squared. So 64 minus 4 times a times c. So minus 40. Over 2 times 1, so 2. Simplify all the way. So -8 plus or minus the square root of 24 over 2. We can simplify the square root of 24. Our 2 factors of 24 would be 6 and 4. 6 would be 3 and 2, and 2 and 2. So we have a pair of 2's. So this would be 2 square root 6 over 2. Can we simplify this anymore?
Yeah.
If all 3 whole numbers are divisible by the same thing, you can simplify. So we're going to divide them all by 2. We get -4 plus or minus square root 6. So we just divided all of these by 2. So that would be our remaining 2 zeros. -4 plus square root 6. And -4 minus square root 6. So here are 5 solutions. Last page of the review is what you guys did on Thursday last week. So just the arrow notation practice. So if you have it done already, you don't have to do it again, but you need to know it for the test. So if you want to redo it, it's good practice. So it says for number 9, as x goes to -3 from the negative direction, where is f of x going? So where's our y going? So as x goes to -3 from the negative direction, where's our y going? Negative infinity. As x goes to -3 in the positive direction, where's our y going? So from this way, where's our y going? Positive infinity. And then as x goes to 1 in the negative direction, so coming from this way, where's our y going? Negative infinity. As x goes to 1 from the positive direction, where's the y going? Positive infinity. As x goes to negative infinity, so as x goes this way, where's our y going? To 0. Awesome. And as x goes to positive infinity, as x goes that way, where's our y going? 0. Perfect.